So in this problem here, we have a steel component that's being suspended from two cables. And we're asked to find the tension in both these cables and comment on whether the cables will fail. So the first thing we're going to do is draw a free body diagram of the system. So we have the weight acting downwards, mg, and we have these two cables acting in this direction here. Now, we can draw some dotted lines there just to get an idea of the angles. Now, if we look back at the picture here, we can see that both these angles make a 25-degree angle. They're both connected at the same point. This is modeled as a particle. There's no difference between there, there, and there. There's no dimensions. So therefore, both tensions must be the same. So this is going to be T, and this is going to be T. In the traffic light problem, we had complete different angles. That's why it was different. If the angles are the same and they're connected to the same point, the same part, then the tensions must be equal. So we'll call them both T. Now, if this is 25, according to the law of alternate angles, this angle here must also be 25. That is equal to that angle there. And so is that angle there equal to that angle there. It's like a Z shape. So, therefore, this angle here is 25, and this angle here is also 25. Now we're going to go ahead and resolve these into two components. The first one being T cosine 25, and we have the same thing here. This is also T cosine 25. Now, we also have vertical components, so we're going to have two here, one for this one and one for this one here, and both are T sine 25. T sine 25. Now, we need to find T, so let's try the x direction first and see how it works. Remember, we've now replaced these two forces, just like the traffic light problem, with equivalent straight forces. And the reason we do that is so that we can keep everything in x and y. Everything is straight. Now, let's go ahead and formulate some equations. Let's start with the x direction. So the x direction is going to be equal to T cosine 25 is equal to T cosine 25. And the reason for that is because it's balanced, so left equals right, up equals down. This is the x direction equation. Now, in the x direction, these two will cancel, so T is equal to T. Now that hasn't given us anything. What it has done is proven that the tensions are the same, in case we were not sure. Now, we're going to have to use the y direction equation then to find T. So we have T sine 25 plus T sine 25 is equal to 2g. So 2g is 19.62, 2 times 9.81, and since these two are the same, it's going to be 2t sine 25 equals to 19.62. Divide both sides by 2 sine 25, and that'll give you a t value of 23.2 newtons. Now, since this is bigger than 5, yes, the cables will break. So in part B of this question, we're now told that the component begins to accelerate horizontally to the right. So we can draw the direction over here and say it's moving to the right and it's accelerating. Now let's draw a new free body diagram. First of all, we still have mg acting downwards, that doesn't change. We also still have these two tensions here. The reason we're redrawing it is because now it's moving this way, so the tension cannot be the same. That only happens if the angles are the same and it's not moving. The angles are still the same, that's still 25, that's still 25. However, the thing is now moving to the right. So this force must be bigger than this one because it's pulling it to that direction. So let's redo these forces again. Now we have to give them names. This is T1, this is T2. Now, let's resolve these two forces. So the first one here is going to be T1 sine 25, because again this is still 25. This one's going to be T1 cosine 25, because that's 25. This one here is going to be T2 sine 25, and this one here is going to be T2 cosine 25. So this is our new free body diagram. Really, all that's changed is that the T is now called T1 and T2. Everything else is the same. Even the angles are the same and 2g is the same. Now let's formulate our equations of motion. So the sum of the forces is equal to ma. It's going this way, so right is positive. Therefore, in the x direction, this must be positive, so T1 cosine 25 minus, because it's going backwards, T2 cosine 25 equals ma. Now, here we have our first equation. Now, let's simplify a little bit. So, let's simplify this equation. First of all, let's take cosine 25 as a common factor. So we get T1 minus T2, both multiplied by cosine 25 is equal to the mass multiplied by the acceleration, both given in the question. Now divide both sides by cosine 25 and we get this expression here equals 2.2. Now this is one equation. Now the only other thing we can do is look at the y direction and get an equation from there. Now this thing is not moving in y, it says accelerates horizontally to the right. That means there's no acceleration in y, that means it's balanced in y. So up equals down. So let's go ahead and put those equations there. So T2 sine 25, which is going up, plus, because that's also going up, T1 sine 25 is equal to 2g, 2 times g is 19.62. Now again, you can take sine 25 as a common factor. Sine 25 is equal to 19.62. Divide both sides by sine 25 and that gives you the second equation, which is 46.4. So we get T2 plus T1 equals 46.4. We now have two equations and two unknowns. So all we do is go ahead and solve them simultaneously. What I would do in this case is I would probably add the two together, because here we have t minus t2 and we have plus t2. So when you add them together, the t2s are going to cancel. So what you're going to get is so put them on top of each other, t1 minus t2 equals 2.2. T1 plus T2 is equal to 46.4. Add them together, that becomes 2T1, that becomes 0, minus plus minus is 0, and add these two together and you get 48.6. So that's an equation. Find T by dividing both sides by 2 and you can clearly see that it gives you T1 is equal to 24.3 newtons. Go ahead and substitute T1 into any of these equations. Let's do this one. Looks easier. So 24.3 minus T2 equals 2.2. Add T2 to both sides, subtract 2.2 from both sides, and you will get T2 is equal to 22.1 newtons.